Welcome to homework.
In this problem, we are asked to calculate the angular acceleration of the rod and the components of reaction at the spot at the given instant of time. That is omega z dot. This is the angular acceleration, and the components of reaction are as dx, dy, then cx, cy, and cz. In order to calculate this angular acceleration and the reaction of components of reactions, we need to apply the equations of motion, for which we need angular velocities and the moment of inertia. So we will start by writing the angular acceleration. The capital omega is equals to small omega, and this is equals to 8k. So from here we can write this omega x is equals to omega y, and this is equals to 0 radian per second, whereas the omega z is equals to 8 radian per second. So from here we can write the omega dot x is equals to omega dot y is equals to 0, and we can say that omega dot z is equals to omega dot z. Now let's write the product of moment of inertia by applying the symmetry. So we can write ixy, ixz is equals to ixy is equals to ixz, and this is equals to 0. Similarly, we can write iyz is equals to 0.75 kg per meter into 1 meter into 2 meter into 0.5 meter. So from here we can write this one as a 0.75 kg meter square. Similarly, we can write izz is equals to 1 divided by 3 into 0.75 kg per meter into 1 meter into 1 meter whole square. So from here we can write this izz is equals to 0.25 kg meter square. Now we can apply the equations of motion as sigma mx is equals to I yz omega z square, and we can write sigma of my is equals to minus I yz omega dot z, and then we can write sigma of mz is equals to izz omega dot z. So from these equations, this set of equations, we can write dx into 4 is equals to minus 0.75 omega z. Similarly, we can write minus dy into 4 minus 7.3575 into 0.5 is equals to 0.75 kg meter per second square kg meter square into 8 square. So from here we can write the value for this dy as dy is equals to minus 12.9 Newton. So from the equation which involves the x components, we can write 50 is equals to 0.25 omega z dot. So from here we can write this omega dot z is equals to 200 radian per second square. So this is the angular acceleration of the rod, and we can write the dx as dx is equals to minus 37.5 Newton. Similarly, we can apply the second law of Newton as sigma of fx is equals to m into ag of x. So from here we can write cx minus 37.5 Newton is equals to minus 1 into 0.75 into 200 into 0.5. So here we have 0.5. So from here we can write the value for this cx as cx is equals to minus 37.5 Newton. In y direction, the equation of motion is written as a sigma of Fy is equals to m into ag of y. So from here we can write Cy minus 12.9 Newton 12.9 Newton is equals to minus 1 into 0.75 into h square into 0.5. So from here we can write the value for the Cy as Cy is equals to minus 11.1 Newton. In z direction, the equation of motion will be sigma of Fz. So this is equals to m into ag of z. So from here we can write Cz minus 7.3575 minus 29.43 is equals to 0. So from here we can write this Cz is equals to 36.8 Newton. So end of the question. Thank you.